Hello, welcome to my YouTube channel. Today we are going to solve the problem 2163, minimum difference in sums after removal of elements. In the problem statement, we are given a zero-index integer arrays consisting of 3 times n element. We are allowed to remove any subsequence of elements of size exactly n from nums. The remaining 2 times n element will be divided into 2 equal parts. The first n element belong to the first part and their sum is sum first. The next n element belong to the second part and their sum is sum second. The difference in sums of two parts is denoted as sum first minus sum second. For example, if you have sum first is 3 and sum second is 2, the difference is 1. But if it's the other way around, the difference will be minus 1. So we are required to return the minimum difference possible between the sum of the two parts after the removal of the n element. So let's dive into it. So my thought process is as follows. Alright, let's take this first example. We can see here in example 1 how to do this. We can either choose first the size of n is length of nums divided by 3, which is here 3 divided by 3 is 1. So we can either choose to remove any of the element. Let's say we remove 3, which should be the correct answer. Then the difference is minus 1. But if you remove 1, for example, the difference will be 3 minus 2, which is 1. Same thing if you remove 2, then you have 3 minus 1, which is 2. So the minimum among all these possibilities, let me put a semicolon. If I put a semicolon, we can see the difference, and the minimum here is obviously minus 1. So the answer is minus 1. But apart from that, if the intuitive way here will be to have a left and a right. So let's say here we have, let's take the longer example. You have something like this. In my intuition, when I start solving it, I was thinking about having something like left and right. And the goal here is to minimize left and maximize right. And to do that, we can use either a sorted list or a heap. But a heap will be pretty simple. So we can have a heap and divide it into two parts. The first part will be from 0 to n. Those will be the first n's, and the rest will be from n. So we'll have basically 2 times n element in the second part. Then our goal will be to use 2 heap, and each of the heap will hold in one on the left. We'll have a max heap, which is basically minus min heap, and on the right, since it's min, we'll have a min heap. Because if you have a min heap, then we can pop the minimum element first and keep only the last n element, which will be the sum of the right. And for the left, same thing, we'll remove all the big elements and we'll be left with only the n smallest element at the left. So the difference will be the minimum possible difference, because you have the minimum sum minus the maximum sum, which will be a negative, or the minimum value we can have. Sorry for that pop-up. Don't know why Java just decided to show up now. And I think we can dive it into the code. So first thing, we can define variable entry, which will be the length of the element, the array, so num, and we have the length of numbers divided by 3, which will define n. So the first part, as explained, will be the first n element, so n plus 1. And here we need a max heap, which is equivalent, we need a max heap, which is equivalent to minus min heap. So if you push the element in the negative of the negation of the values, then it's basically a max heap. So we have the total on the left will be sum of the numbers. So we'll take the first n numbers. What will be the total? And let's say we have the q left. The left q will be minus x, or x in nums. So we push the first n element to the queue, and we can use happify. Happify, is it how we write it? Happify, sorry for my spelling. Happify, and we pass the q, which will be left q. And then the first element of the part will be total. And for I in range n to n times 2, or 2 times n, is commutative. So basically this is the middle part. What we'll do, we'll add total plus will be nums I, and we add it. If you add an element to the sum, you have to add it to the heap. So heapify heap q, heap push q left, and minus num I. Yeah, so it's basically, and after doing that, then we have to, if you pop an element, we have to remove one to make it an element. So we remove the maximum. Here we remove the maximum element because you want to only have the n smallest element. So will be minus heap. Since you are pushing it by negative, you have popping, you have to put it back again to its normal value, which will be minus. So, and then we update the value of part. So we have part of I minus n minus 1. So why this? Because you are starting from n. That's why, so to update the part which is part 1, so we'll have basically the value here will be from n, so it will just be the index, and that will be total. So we update the value of part 1, and then that's done for this part. Then we move to the right part, which will be in min heap. So part 2, same thing, it will be the sum of nums and times 2 by 1. So the second part will be from 2 twice m up to the end, so to 3n. And the heap queue, then you push it. Heap try, let's make it a heap. No, oh, before the heap, we make the right heap. The right heap will be okay, nums twice and to the end, and then heapify the right queue, and the answer will be the part 1 at index n, which should give us the minimum value, and part 2. And now we have to iterate through from twice n and then downward to update the value of the right heap basically. So in range twice n minus 1 up to n, so we have to remove minus 1. So we are going from twice n minus 1 to n, and part 2, since you are adding it to the heap, you have to add it. Part 2 plus will be nums, and we heap queue, heap push, sorry, and here write nums I. So push it to the heap, and then now we remove the smallest value to the top of the heap, since it's a min heap. Heap pop right q right and nums I. Now we just have to update the value of num will be the minimum. The answer will be minimum between answer and part I minus n minus part 2, and we return n answer. So this is the answer. I hope you understand it. It's pretty short, but the idea is clear, pretty simple. I think we can also use, if you want, shorted list to solve it. So basically it's the same thing. Then you have a shorted list or two shorted lists, which will just have, because by default a shorted list is a heap, a min heap. Somehow it depends if it is short from smallest to biggest, it is a heap. So based on that one, on that ideology, you can use a short list too. So let's test it. Labels. So, uh, all right. Okay, let me just remove these comments. I think they've done their jobs. Because it's talking about the indentation. For in I don't know what's wrong with me. In uh, where is it? Name is not part one. Yep, it's part one. Part one. Oh, sorry for the errors. Oh shit. I don't even know. It's not the correct way. Popping have to be. Yep, it's working. So at least you pass here. Let's see. So it's okay. Passes. It's not the fastest one. But the time complexity, yeah, it will be, since you're shorting, I mean, you are using heap, I mean, it's n log n, and also the space complexity, but it's n log n times, I think something like, yeah, it's because, let me see for line, because, yeah, I think it's n times log n because of the heap part. Heapifying is log n, but since you're doing it for n elements, I mean, basically, then it's, yeah, it's n times. And the space complexity will be, since you're storing using this, it's n also, because you're using this part one to keep uh, track of the values sum for each index in the first part. So basically, it's also of n. So thank you for watching. Please subscribe, like, and share. Peace out.